Okay, guys, so handout 7, it has two parts as I mentioned in my previous class and at the beginning of the class. This handout 7, part 1, we did, derivative of exponential function, both natural exponential as well as the generalized exponential function. And part 2, we'll be focusing our attention on derivative of logarithmic functions, two kind of logarithmic functions, okay? One is natural logarithmic function, and another is generalized logarithm, okay? So natural logarithm is, I think you have seen this kind of ln x, okay? This ln is natural logarithm. And another type is this. So this is generalized logarithm, okay? So these types of two types of logarithmic function. We'll be looking at how to find the derivative of those kind of function. So I believe you know what is logarithmic functions, right? So a logarithmic functions is defined as follows. As you can see, log to the base a x equals y. What it means is ay equals x. In another word, this exponential functions can be changed into logarithmic functions. I think you have done that in your high school. Let's do few things, okay, here, just for fun. Let's say 10 square is 100. And I want you to change this into logarithmic function. How do you write that? In logarithmic functions, this will be log, base will be 10, and then you switch the power and this 100, 2 and 100. So this will be 100 there equals 2. So these two things are equivalent, okay? They mean the same thing. Suppose you are given 5 cube equals 125. So if you want to write the same thing, I think you are much more familiar with this type, but we can write the same thing using logarithm, okay? If you want to use the logarithm, that's gonna be log, base is here, the base is 5, base will remain the same, and you switch the power here and this 125. So that will be 125 equals 3. Okay, now you have seen this ln x. What does that mean? This means it's a logarithm of base e. When the base is natural number e, then we write that, we call this natural logarithm, okay? So ln x, I call it ln x, ln x in short, okay? That means it's a logarithmic functions with base e. If I simply write log x, for example, then please note that this means log, even though the base is not there, but the base is 10. When the base is 10, then we don't write base there. But if you write this way, that's fine. But the mathematical convention, mathematical tradition is that when the base is 10, we don't have to write it, okay? So please remember this. Couple of things from high school. We are actually reviewing from high school right now. Couple of things. The domain of the logarithmic function is always positive number. So for example, if you write ln 0, it is undefined. You can try this putting in your calculator. If you put ln 0, or you can put log 0, still undefined. If you put ln -1, for example, still undefined. So what it means is the domain for logarithm is always needs to be positive number. Just keep that in mind. Therefore, a lot of time for logarithmic functions, we just put the absolute value sign like this to make sure that this value is positive. Okay, now these are the properties I want you to recall from your high school. Product rule, log of a product. For example, if you have log to the base a, x, and y, it can be written as log ax, log to the base ax plus log to the base ay. This is a constant, okay? In the same manner, for natural logarithm, the same rule works. So when you have natural logarithm x times y, we can write this as ln x plus ln y. So the quotient rule is here. If we have x over y, we can write log to the base ax minus log to the base ay. Same with natural logarithm. So they share the same property, by the way. Log of power. So if we have log to the base axn, the power is there, then you can write that, and here log to the base ax. Same with natural logarithm. Okay, and log of a reciprocal rule. So if you have log 1 over x, we can write down that as log to the base ax, because you see this guy is log a. You can write x to the power -1, because 1 over x is x to the power -1. Using the log of a power, you can write this power at the beginning, 1 log to the base ax. Okay, that's what you can do, which means basically this. Same rule applies with natural logarithm. Log of the base. Log to the base a, you see the base a and a, it will be 1. Same with natural logarithm e equals 1. So log of 1. So if you have log to the base a1 equals 0. The reason is simple again, because a power 0 is 1. So if you want to write this in logarithmic notation as we did earlier, what you do is log, the base is a, and you switch this. So 1 equals 0, right? So that's what it is. All right, so quick high school review. Now I want to take you back to the college concept, because our goal here is to find the derivative of logarithmic functions. So let's focus on our main goal for this class. Find the derivative of logarithmic functions, both types of logarithm. And here is the formula, guys. The proof of the formula is beyond the scope of this course, but those who are interested, I think I will provide you the proof in the lecture note, or maybe you can see in your textbook. But again, the proof is not required for exam point of view. So remember this. Derivative of, okay, let me start with this first. So derivative of natural log x equals 1 over x. By the same token, you have here natural derivative of natural log g of x equals 1 over, we are using the chain rule here, 1 over g of x, and then you find the derivative inside, which is g prime of x. Okay. Now, derivative of generalized logarithmic function is pretty much the same, but the one thing we need to keep in mind is that we need to write one factor extra. So the logarithmic, log to the base a g of x equals 1 over g of x times g prime of x times 1 over ln a. This is the extra factor that you need to write from this natural logarithmic functions. And using this formula, we'll be solving these questions now. Let's look at example 1. Find the derivative of the following. So in this case, we'll focus our attention on natural logarithmic functions only. And example 2, generalized. So part A, y equals ln 3x. So your derivative d over dx will be d over dx of ln 3x. Using rule number 1, what you get here is 1 over, you see, ln g of x. So 1 over g of x. So that gives me 1 over 3x. And now you find the derivative of 3x because using the chain rule. Okay, so the main function here, I call it mother function here, is ln 3x. So using the natural logarithm rule, we have 1 over 3x. And now, you know, we did the derivative of the mother function, leave the baby inside. And then now you find the derivative of the baby inside, which is 3x derivative, which gives me 1 over 3x times 3, and 3 cancel out 1 over x. Okay. Okay, let's try part C. F of x is given ln x. So your derivative is going to be, first you need to find the derivative of the whole function, which is ln x. Find the derivative of that. And then you need to find the derivative of this. So that means derivative of this one will be 1 over ln x, and derivative of ln x will be 1 over x. So your answer is 1 over x ln x. Any question, guys, so far? Okay, let's try part E, maybe F. Y equals ln x plus 1 and then power 4. So here we have to use the chain rule 2 times. Use chain rule twice. Because the mother, I would say grandmother function here. Okay, so grandmother, mother, and then the baby inside. So first we need to find the derivative of this whole function, which will be 4 ln x plus 1 power 3. So we are done with the, you know, with the mother, I would say grandmother function, okay? And then leave the mother inside. Now you need to find the derivative of this guy inside, which is ln x plus 1. We need to find the derivative of this. So this is going to be 4 ln x plus 1 power 3. And now derivative of this, using that rule number 1, you will get 1 over x plus 1. And then we need to find the derivative of this x plus 1 derivative. Okay? Derivative of that. Remember, for the derivative, I'm using this little bit slanting symbol, prime, x plus 1 prime. So then this will be 4 over x plus 1 ln x plus 1 power 3. And then derivative of x plus 1 is simply 1, so I don't have to write that, just that becomes simply, you know, 1. So no need to write this down. Any question, guys, so far? So then derivative will be y prime, which is 1 over x squared minus 5, and then we need to find the derivative of x squared minus 5, which gives me 1 over, that will be 2x. So 2x over x squared minus 5. Thank you. And going back to part E. Okay, let's try part E. And I think you guys did pretty good in part E. So that's, let me just copy the question. Y equals ln negative 8x cubed plus 2x. So your derivative is going to be 1 over negative 8x cubed plus 2x. And then we need to find the derivative of this guy, 8x cubed plus 2x. Okay, so that means we're gonna get negative 24x squared plus 2 over negative 8x cubed plus 2x. That is our answer. And part D, that is interesting, and I give you a few more minutes maybe to work part D, and then we will go, we'll check what is the best method to find the derivative of these kind of functions. Okay. Okay, so using the quotient rule here, you have this 1 over, using the logarithmic rule, we have 1 over x cubed plus 4 over x, and then derivative of this inside part, and then you flip it, you're going to get x over x cubed plus 4, and using the quotient rule, so that will be u prime, which is 3x squared, and copy v, which is x, minus copy u, x cubed plus 4, and then the derivative of v, which is 1, over v squared is x squared. So that's going to give me x over x cubed plus 4. And then you're going to get 3x cubed minus x cubed minus 4 over x squared. And so I'll get, okay, this x squared and x, you can cancel one of the factors. So you're going to get 1, you know, on this side, you'll have 2x cubed minus 4 over x times x cubed plus 4. Is that right, Q? That's what you got, right?
I think I did the wrong thing because I used x squared, not x cubed. Sorry about that.
Okay.
I write out the question and I use the x squared, not x cubed.
Okay, so you copied the wrong question. Anyway.
Yes, because it's very small, so I just did it
Yeah,
not carefully. Sorry about that.
That's okay. I mean, your answer is correct for your questions, right? So right now, it's okay. In the exam, that may be a problem, but not now. Anyway, but you know what? If I were you guys, so I would do this problem in a different way. If I were you, what I do is this, I will write this as, you see the rule, ln x over y equals ln x minus ln y, right? We know this. So I will use that rule. So I'll get ln x cubed plus 4 minus ln x. I just do that using the, you know, this rule. And so my derivative is going to be 1 over x cubed plus 4, and then the derivative inside, which will be 3x squared minus 1 over x. Done. I would do this way actually, but method 1 is also perfectly fine. But the only thing is, you know, it takes a little bit of a time, but method 2 is shortcut, right? So your answer is going to be 3x squared over x cubed plus 4 minus 1 over x. Okay, so the generalized form, you know, derivative for generalized logarithmic function is this. let me write g of x. So you have 1 over g of x times z prime of x, same as natural logarithm, but one factor extra we need to write. This is the formula we will be using. Now let's try part A. So using that rule, derivative will be 1 over x, and then you need to find the derivative of that x, and then 1 over ln 8. But we know that derivative of x is 1, so basically what we got here is that 1 over ln 8x, or you can write x ln 8. Done. Let's try part C. F of x is logarithmic function log to the power log to the base 4 x squared plus 1. I think you guys can do it easily. So same thing as before, only one extra factor we need to write. So that's going to be 1 over x squared plus 1, derivative of this, and then you need to find the derivative of this part. And then one extra factor, natural log 4. So this will be 2x, derivative of this part, over x squared plus 1 ln 4. Okay, any questions so far? Let's try part D. I know you can do this, but let's try that just for fun, okay? Part D is f of x equals x cubed log to the base 5x. Now remember, this one is a product of two functions. One function, the first function u is x cubed, and your second function v is this. So we need to use the product rule first. So this is going to give you f prime of x equals ub plus ub prime prime. So u prime will be 3x squared, copy v, which is log to the power 5, log to the base 5x, plus copy u, which is x cubed, and then the derivative of that. So derivative of this guy will be 1 over x, and derivative of x will be 1, I don't have to write that, and one extra factor, 1 over ln a, which is base is 5. That's it. Looks a little ugly, so let us write it in a nice form. 3x squared log to the base 5x plus this guy will be x squared over ln 5. This is our answer. Any question? Okay, no question. Then I want you to try this parts B and E. Okay, guys, I know you can do it, but let's try. Let's do it just for fun again, okay? Part B and part E. I want you to try these two questions right now. Everyone is okay with that? So when we are given y equals log x, that means the base is 10, as we discussed at the beginning of the class, or you learned from high school. So now you can use the formula, which means 1 over x and then derivative of x is 1. I don't have to write that. And 1 over ln 10. So that is your answer, which is 1 over x ln 10. Thank you, Q. Now, part E is, I know you have already done, many of you have already done, but let us verify the answer right now, okay? Log 4, 5x plus 3x cubed. So your derivative is going to be 1 over 5x plus 3x cubed. And then you need to find the derivative of this 5x plus 3x cubed. You need to find the derivative of that. And then you need to find you need to write one extra factor, which is ln 4. So that's going to give me 5 plus 9x squared over 5x plus 3x cubed. And then this will be ln 4. Any question, guys, so far? Okay, so we learn how to find the derivative of both type of logarithmic function, natural logarithm and generalized logarithmic function. Now, the question is, can we apply this concept to solve real world problems? Of course we can, right? So one simple example here is example 3, and then after that we'll use, we'll solve another problem as well, real world problem. So I would like you to try this. Please read the questions very carefully and try to answer these two questions. And maybe, yeah, so try this. And another example, we'll do that after the break. So the example is in a psychological experiment, students were shown a set of nonsense syllables such as POK, RIZ, DQ, and so on, and asked to recall them every second thereafter. The percentage R of X, remember the R of X represent the percentage of the student who retain the syllables after T second, okay? And this is given by R of T equals AT minus 27 ln T. So this model that situation. Now in part A, we need to find the percentage of student retain the syllables after 1 second. So that means given R of T equals 80 minus 27 ln T. So part A, we need to find when T equals after 1 second, when T equals 1. So after 1 second means T equals 1. Your R of T equals 80 minus 27 ln 1. What is that? Ln 1 is 0, right? Ln 1 is 0. We know that. Ln 1 is 0. So that's going to give me 80. So 80%. 80% of the student retain the syllables after 1 second. Now, part B. Find R prime of 2 and explain what it represents. So first, let us find R of T, the derivative of this function, which is negative 27, and derivative of 80 is 0 minus derivative of 27 ln T will be negative 27 times 1 over T. So that's going to give me negative 27 over T. So your R prime of 2 is going to be negative 27 over 2, which is negative 13.5. And since it is in percentage, you can say this, this is in percentage now. What does this mean? Okay, Q, excellent. So after 2 seconds, the percentage decreases by 13.5. Yes, that's what it is. So the meaning is after 2 seconds, the percentage of student who retain the syllables decreases by, or you can say after 2 seconds means at, yeah, after 2 seconds, yeah. At 2 seconds you can say as well. Syllables decreases at 13.5%. That's what it means. Any question, guys? Guys, can you see my screen in your, my handout in your screen? Okay, thank you. Yeah, so example 4 is, it's another application of logarithmic functions in real world, especially from economics. Suppose the demand function for Q units of a certain item is given by P equals 100 plus 50 divided by ln Q, where P is price in dollars. Find the marginal revenue. Approximate the revenue from one more unit when 8 units are sold. Okay, guys, so let's try this. First of all, you see the price is given and we need to find the marginal revenue. In order to find the marginal revenue, we need we need a revenue function. Can you think of how we can find the revenue function here?
We multiple demand function with the price.
Yes.
With the quantitative.
Yes, yes, price times quantity. We know that. Revenue is given by price times quantity. Everybody know that, right? Now, price is P, so I have revenue equals price is P, which is given this 100 plus 50 divided by ln Q. This is your price times quantity is Q. Okay, so that means your revenue function is going to be 100Q plus 50Q over ln Q. Now, guys, I would like you to find the derivative of this. And I'm sure you can do this by yourself. So derivative of this will be, derivative of 100Q is simply 100 plus derivative of 50 cube over ln cube. We need to use the quotient rule here. Quotient rule. So what I do is I will just find the derivative of this here and I just copy this later. Okay, so d over d cube of 50 cube over ln cube. This is your u, this is your v. We know the formula, uv minus uv over v squared. So prime prime. So that's gonna give me the derivative of the u means 50. Remember the variable is q here. And copy v, which is ln q. Notice that for my q, I just write q this way. This is my q, because a lot of time 9 and q, when I write that way, it's just confusing. Which one is 9 and which one is q in this case, right? It's a little bit difficult to distinguish. So for that reason, my 9 is just like this, the straight leg, and then the q will be the broken leg. Whenever you see the broken leg, then that is q. Okay, just keep that in mind. Okay, so U prime is 50 and copy V minus copy U, which is 50Q, and then B prime, which is 1 over Q, over V square is ln Q square. So let me just copy this. So this Q and Q cancel out. So you will get 50 ln Q minus 50 over ln Q square. Okay, so that's the marginal revenue. We're done. Part A. Part B. Approximate the revenue from one more unit when 8 units are sold. What does that mean? It means we need to find R prime of 8. Remember here, when 8, one more unit, when 8 units are sold, that means we're trying to find the revenue from the 9th unit. So this means, this gives us a revenue from 9th unit. That's what it means. All right, so R prime of 8. That's the definition of this, marginal revenue. And so when you plug in the 8, Q equals 8, you're going to get 100 plus 50 ln 8 minus 50 over ln 8 square. Can somebody tell me using your calculator? I don't have calculator, so let me know what is the answer here. Okay, anyway, I use my calculator. My calculator gives me $112.48 per unit. You guys got the same thing? Okay, thank you, Q. We got the same thing, so that must be the correct answer then. All right, so what it means is, so the revenue from the 9th unit, when you sell 9th unit, this will be the revenue.